Hi friends, welcome back to Mule4 series of learning videos. I am Siva.thankamanee, an integration technical architect. In this small video, we are going to see how to design the integration design pattern called wiretap. And we have been using this wiretap design pattern unknowingly whenever we design API. But I want to highlight some specific design when using wiretap and the benefits and some methods to add the monitoring in the MuleSoft API. Let's get started. So wiretap design pattern is designed to resolve some intended problems. So the necessity here is to monitor the API. For example, in an e-commerce application, we might have several different APIs called online orders and then order fulfillment, etc. So we have so many APIs in e-commerce order management, and one of the critical API is to receive the order from the online users. So while receiving it, you want to monitor the API, and also you want to keep track of the count of requests that's coming in, so that you want to monitor and then take decision accordingly. And also you want to measure the payload size to see if payload size impacts the performance of the API, or how or what is the standard deviation between these request size. So you want to do several different monitoring aspects, but at the same time, you don't want to impact the existing API because of adding these additional burdens and monitoring capabilities. So this wiretap resolves that particular technique by not impacting the existing API. So the wiretap technique routes this payload to the dedicated monitoring API, and then that dedicated API keeps track of the count and the payload size, and then we create a dashboard to visualize the number of requests that are coming in. This could be for one API, or it could be for a set of APIs. Based on the use case, you can combine and play around. So normally we recommend to create one API for monitoring purpose, and that can monitor multiple APIs, probably by using this client ID or by some ID mechanism. And at the same time, you don't want to impact the existing APIs by deploying this monitoring API into a separate vCore, so that it runs on a separate container in a runtime plane, so existing APIs don't get impacted. So let's get started and see how this wiretap can be designed. So before we start looking into wiretap design pattern, we need to do some monitoring API, and then we need to take care of a few specific things and configurations so that we properly design this, which can be used by all APIs. So it's very important to create this in a particular way. So we have created an API, which is named as Experience Monitoring API. And this monitoring API should not contain any other functional features, and it should only be used for monitoring purpose. And it might contain a necessary feature where you want to store the payload into the database, or you want to put it in FTP for a data warehousing purpose. So you can do all that here. And the more importantly, it's capable of receiving the payload, any payload from any API. And it doesn't process the payload, or probably it performs some fuzzy logic based on the payload content and makes some necessary action. So it's up to you to design the features, but however, there are some specific things that we need to observe. So we have the properties that enables the analytics for this API. So we have seen in the previous video on how to create an API with these analytics enabled. So you need to have this API with a RAML, and it's designed, and RAML, based on the RAML API is created, and metrics is enabled. So the analytics metrics is enabled by using this analytics base URI, and also we are enabling this auto discovery aspect by giving this anypoint platform client ID and secret, which we have seen in the previous video. You can click on this name of the organization, click on business groups, and you can click on the environments, and you can choose the particular environment where you want to deploy this monitoring, and then you can create you can see this client ID and client secret and configure this. This is how we need to configure. You can go through my previous video on how to do that. So we must have this analytics enabled in order to create some custom or built-in metrics. And also we have created an API, and we have given this API ID in the auto discovery. So all these have to be done, and the API is prepared. Let's go to this API manager. And we have this monitoring API created. So I have already posted a video on how to create a simple API based on the RAML. So take the RAML and then create an API by using this create new API and import RAML, and then you create all this. And once you create the auto discovery and configure and bring this API up and running, automatically when the application is up and running, this API also will be enabled by being active. And then you can click here. And we have enabled the policies, the basic policies like client ID enforcement, which will be sufficient for us to do this. And this is the basic thing that we need to do. And we have the application up and running. Let's go to this runtime manager. And this API is up and running, so that we are ready to do this monitoring using this API. So now let's focus on the topic called wiretap design pattern. So I have created a simple MuleSoft flow, and we can assume that this API is the intended API where you want to monitor without impacting its actual performance. So assume that this API is order receiving API where you receive online orders, and there are some functionalities which we don't want to impact. And in order to enable this monitoring, we are going to add asynchronous scope. So asynchronous scope runs this thread asynchronously without impacting the performance of the functionality of this API. So let's call this asynchronous as monitoring. Send monitoring details. And here you need to call HTTP request, where you are going to invoke this monitoring API which we have deployed. And so this is the monitoring API which we have run separately. So this is the URL, and this is a resource path called monitoring, and you can give any payload. There is no restriction, because the purpose of this monitoring API is to count how many requests are coming in for various APIs put together, and then what is the size of the payload. So that's what is important. So we are having a simple hard-coded response called success when we run it. So this monitoring API is up and running fine. We have a client ID, client secret enforced. We are giving it via header, so everything looks fine. So we need to make use of this endpoint to send the details in order to enable this monitoring. So double click it and create the configuration and give this HTTP, and you need to give this host. Let's copy this and give the host, and port is always 80 for all the Cloud Hub APIs. Let's say OK, and this method must be post, and the path is / monitoring. You can copy it from here, and that's it. And we need to add the client ID and client secret into the header. So go to header section, click add, and let's say client ID. I have taken the values here, so let's copy that. And we need to give it within the double quote because it's a string. In the same way, we can give client secret. Let's go to the value, copy this. So we simply have just invoked this monitoring HTTP API, which is basically a REST API with a post method enabled. And whatever payload is given will be sent to the request to the monitoring API. But if you want to just only keep track of the count of the requests, you don't need to send the payload. It doesn't make sense to send the entire payload to just keep track of a number of requests. But if you want to measure the size of the payload and then visualize, then you can go ahead and send it as payload. Otherwise, you can hard code some simple hard coded request to go to the monitoring API. So this is as simple as that. And now we need to run this API. And so this is order. Let's create another REST API here. I'm using SOAP UI tool. You can use Postman tool. This is because it's a REST API. Localhost 8081/order. This is the order API which we have just developed. And so this is the order. So we will say order ID 123 customer. We will give some name and let's give this. So we have simply given the response saying that your order is received. So we received it successfully. And so we have also done additionally by sending this a payload to the monitoring API. So which goes to our monitoring API, which we have deployed here, which is running in a separate vCore, which is not impacting the performance of this online order API. So now we should have received this payload here, and this received payload here. And let's run this for quite some time, say multiple times, and then see how we can monitor this API. So the beauty of this wiretap is you can add this section to multiple APIs or whichever APIs you want to monitor for number of requests, because there are some critical APIs where you want to keep track of the count, and that alone can have this section where you want to send the payload for monitoring purposes. So let's go back to this and then see how this monitoring can be done. So let's go to the monitoring section. And if you want to see the count, simply you can view by using this built-in monitoring feature. So you can see the number of requests. And the other way is, which we are interested, is to go to API manager and go to analytics. And you can choose the custom dashboard, which I have created here for our monitoring purpose. So this is the dashboard that we are going to see, which is enabled for this monitoring aspects. So if you are running your API, the API can run anywhere. It could be a .NET application, or it could be PHP, or it could be a Java J2E application, or it could be any other web applications running in your web application, where you can still enable this monitoring, because this is running separately on a separate vCore into the Cloud Hub, where API monitoring is enabled. So now we can see here, these are the requests that we have recently updated. So let's refresh this. Now you can see various requests added. So this is the one that we have just given, because it's 6:15. We have given it 4 minutes back. So how to create this dashboard? So you can go to manage charts, and then you can create a new, and then you can create this chart. Let's give this. So you want to see the number of requests, monitor order requests. So you're giving the title for the chart or the visualization that you are going to create. And let's copy this into the description. And now we want to only monitor one column. It's very simple. So let's choose this monitoring API, not all APIs, because we are interested in some specific action. So we have a request size, number of requests, response size, and the response time. You can choose anything which you are interested. Here response time doesn't make any sense because actual API is different. This is monitoring API where you want to only monitor the number of requests, and you can choose the interval based on which this monitoring details are to be collected. So we can choose by every minute and then save chart. So that's it. So you can, so this is a one which we created. So you can so this is ready and can be used by the ops team to monitor the number of requests, or when it's peaking, or when there is some issue occurs, when you see if the number of requests going or exceeding some predefined number of requests, you can take action accordingly. You can increase the vCores, or you can increase the number of workers, and you can play around accordingly to manage the load. So now beauty of having this separate API that you can add different perspective into the dashboard. So let's see how to do that. So I have already created there are two charts available which we have created one right now, and I have created one. There are two visualizations that we created, and probably what we can do is we can edit one of them for payload size and one of them for number of requests. So let's edit this number of orders and order payload size. Let's copy this. So order payload size monitoring, and instead of request you can choose request size and then save chart. Now we need to add these both perspective into the dashboard. So let's go to the custom dashboards. So this is the default dashboard that you are seeing, and it contains only one which I have already added. So you need to choose this edit dashboard, and then you can drag and drop this one. So we have two, and one is order payload size and another one is monitor order requests. So let's save this. So let's refresh this, and now you have both. So one to manage the payload size and one for the number of requests. Now let's see how this works. So now let's create or inject a number of requests like 10 or 15 requests, and then let's refresh this. And it will take a few minutes to get it reflected, and you should not see it immediately. And yeah, we refreshed. Now we are going to see some huge payload, and let's see how to create it. So let's create something here, and let's copy this. I'm going to copy this repeatedly. Let's do that. So I have purposely enlarged the payload size. So I have created, and then let's copy this again one more time. So we copied multiple times. Let's give this. So we see various size in the dashboard. Okay, let's go back and then see. Now you see here this contains more than 2K payload size, which is obvious. We have created multiple requests with varying size. Let's refresh this. So also you can see here number of requests exceeded 20 in this particular time frame because we have given too many requests back to back. So you can see the number of requests and payload size at the same time by using this dashboard. So while explaining, I thought people might have some internal confusion and will ask questions why we are creating a separate all new API while API manager has inbuilt mechanism of monitoring the APIs directly. So you need to understand the two completely different things. We are not talking about monitoring MuleSoft APIs. So we are talking about monitoring any web services that are available in the organization. So those web services might not necessarily be an existing MuleSoft API, but it could be a .NET service, or it could be a Java J2EE service, or it could be PHP service. So you might want to monitor multiple systems it could be an omni-channel where you have e-commerce applications receiving the order that you want to monitor. So you can have this monitoring tool as a separate API deployed in MuleSoft, but the underlying details that you can collect the information from various sources. So it's a very simple one. You just need to call a HTTP URL and then send in the payload in order to enable this monitoring. It's that simple. So that is number one. Number two, even if you want to have API that are created in MuleSoft that you want to monitor, it's up to you to have multiple API monitoring analytics added onto this API, because nothing comes free. It's all comes with some expense. So whenever you keep adding this monitoring aspects into an existing API, we are adding burden to the API directly or indirectly. So in order to avoid that, we prefer to have this monitoring API in a separate vCore without disturbing the existing API. And then you can keep adding multiple features into this monitoring API so that you have everything under control, and then you can play around according to the use case. So the benefit of having this API is to multifold. You can monitor, and the ops team can monitor the size and then take proactive actions. And also you can do some what you call capacity planning, and based on the number of requests, if you see the order trend is increasing, you can increase the vCore size of the specific API that has too many requests. So it is used for multiple purpose. Once you have API monitoring is in place, that can be definitely used for multiple purposes. So that's it in this video. Hope you liked it and felt it useful. And if so, please hit thumbs up button and subscribe my videos. Soon I will come up with more interesting topics. Thanks again for watching this video. Bye.